In this video, we're going to solve quadratic equations by completing the square. We're going to follow these 5 steps for each problem to help us learn how to do the completing the square technique. The first thing we want to do is check out the coefficient of our lead term. So if the coefficient of x squared is positive 1, then we can go directly to step 2. In our example, we have our lead coefficient of positive 1. Step 2 says to isolate all variable terms on one side of the equation. So x squared is a variable, 14x is a variable, 33 is not a variable. So positive 33 will need to be moved to the other side of the equation using the subtraction property of equality. So we'll subtract 33 from each side of the equation, and that will leave us x squared plus 14x is now equal to negative 33. Step 3. Complete the square for the resulting binomial by adding the square of half of the coefficient of x to both sides of the equation. Our coefficient of x is positive 14. So we're looking for half of 14, first of all, and 14 halves would make 7. And then we need to square that quantity of 7. And this amount, 49 in this case, is what we need to add to both sides of this quadratic equation to create a perfect square trinomial. In other words, we'll have x squared plus 14x plus 49, and that equals negative 33 plus 49. So whatever amount I'm adding to the left side of the equation to create a perfect square trinomial, I must add that same amount to the right side of the equation to balance it. Now I've used the term perfect square trinomial, and we know from previous lessons in factoring that perfect square trinomials factor as binomial squares. And we have a clue as to how this factoring will look in the previous step. When we found half of 14 to come up with 7, 7 is the amount that's going to show up here in this binomial square. And since it is a positive 7, I know that I'll have x plus 7 quantity squared. Now we just have to do the arithmetic on the right-hand side. I have 49, subtract 33, and we're going to end up with 16. So now I have my binomial square equal to 16, and to complete the solving of this quadratic equation, we now apply the square root property. We have a perfect square on the left-hand side of the equation, so we're going to take the square root of that perfect square quantity, and we're going to find the square root of the value on the right-hand side. But what we need to realize is that when we have quadratic equations, we have 2 possible solutions. So we have to consider both the positive root of 16 and the negative square root of 16. So the square root of 16 is going to turn into positive or negative 4, because 16 is a perfect square. Once you take the square root of a perfect square, remember that is opposite operations, so they are undone, leaving us simply x plus 7 equals plus or minus 4. So we need to separate this into 2 separate equations and then solve each one individually. So my first equation, would become x plus 7 equals negative 4, or we could have x plus 7 is equal to positive 4. Now let's solve each of these linear equations using my subtraction property of equality again. I would end up with x equals negative 11 for one solution, and subtracting 7 for this other linear equation, this answer is x equals negative 3. In example 2, we have x squared minus 11x plus 30 equals 0. So first we're going to check out the coefficient of our lead term. And again, the lead term, remember, you need to have your quadratic equation written from highest to lowest power set equal to 0. So x squared minus 11x plus 30 equals 0. That's already in our standard form. Our lead coefficient is positive 1. So we're going to move this constant term with subtraction. So that leaves us x squared minus 11x now equals negative 30. In order to find the amount to add to both sides of the equation that would create a perfect square trinomial, we need to find half of our middle coefficient here, the negative 11. This is a negative number, so half of a negative number is going to be negative 11 halves. We also now need to square this value of negative 11 halves. When you square a negative number, you'll have a positive product. 11 times 11 is 121, and 2 times 2 would make 4. So notice we ended up with a positive fraction here. So the new quadratic equation is x squared minus 11x plus 121 fourths is now equal to 121 fourths minus 30, because we had negative 30 on the right-hand side of our equation. We are going to need to work with these two constant terms, but in order to combine them, we need to have a common denominator. So if we think of 30 as 30 over 1, we can build that up. Let's go over here. 30 over 1 needs to be built up by some factor to convert it with a denominator of 4. So 1 times 4 would make 4. That means 30 must also be built up by a factor of 4. 30 times 4 is 120. So the equivalent of subtracting 30 over 1 would be to subtract 120 fourths. So I'd have 121 fourths minus 120 fourths, and that is equal to 1/4. So that wasn't so bad to subtract. So our quadratic equation now, let's go over here, x squared minus 11x plus 121 fourths now equals 1/4. We should have a perfect square trinomial here on the left side, and that factors as a quantity squared. So x squared comes from x times another x, and going back to where we found half of negative 11, the negative 11 halves is the amount that will be used in this binomial. Notice this time I'm using subtraction of 11 halves, and that all stems from this middle term in the original equation being a negative number. So half of that negative number makes a negative number. Now we're going to take the square root of each side of the equation. However, we want to remember that we are considering both the positive and the negative square root of 1/4. So we are undoing this squaring to get x minus 11 halves now is equal to the square root of 1/4. The square root of 1/4 can be thought of as the square root of 1 or the square root of 4. So square root of 1 would be 1, and the square root of 4 is 2. So again, we're considering plus or minus the square root of 1/2. So now we can go ahead and set up our two equations to solve and get our two solutions. One equation will be x minus 11/2 equals negative 1/2, or we're going to have x minus 11/2 equals positive 1/2. So if we go ahead and add 11/2 to both sides of this first equation, we're going to get x equals 11 minus 1, or 10/2. We can simplify that as x equals 5. So one solution is x equals 5. For the other equation, we'll go ahead and add 11/2 to both sides of the equation. Here we're going to have x equals 1 plus 11 to make 12 in the numerator. Denominator is 2. And again, 12/2 is a fraction that can be simplified. So here, x is going to equal positive 6. So we have two solutions, positive 5 and positive 6.